All right. First thing we're looking at this course, concept really doesn't tell us a whole lot. Square root of a negative number property. So if we take a number r, real number r, and then say we take the square root of negative version of that number, it's going to equal r times the square root of that number. That's all that's saying. So if we took, say, 5, so we'd have the square root of negative 5, the negative would come out as I, and then we'd figure out what the square root of 5 is. That's all the first line saying. Second line saying, if that's true, and we take that I square root of 5 and multiply it by itself, we'll get back to negative 5. All I'm saying is that those two will undo each other. We'll get back to what we started with, negative 5. So yes, that's good to know. Yes, it does say stuff, but for the most part, for us at this point, it doesn't tell us a whole lot. Saying that we can take the square root of a negative number. And if we square it, we get back to the number we started with. Now, we haven't done much solving with with getting complex numbers as solutions. So the first few things we're going to do is solve these here. X squared plus 4 equals 0. Now we could try graphing it. We could say x squared plus 4 graph. Does it cross the x-axis? No, so it tells us our solutions are non-real. We don't have real solutions, but that's fine. We know how to find them now. So that means graphing doesn't work. Factoring also doesn't work. But the only variable we have in this equation is x squared, which means we can use the square root method. Because the only time we can use the square root method is if the only variable we have in the equation is x squared, or the variable being squared, or the only place it's located is inside a set of parentheses being squared. So here we can use the square root method. And the first thing we need to do is get the term being squared by itself. So the first thing we can do is subtract 4 from both sides, telling us x squared is equal to negative 4. Is the squared term by itself? Yeah, so we would do what? Square root both sides. And on the left-hand side, the square root and square would cancel, giving us x. And whenever we take the square root of both sides, we have to put the plus or minus. So we have x is equal to plus or minus 2i. Now, when we square root this, the graphing calculator will take the square root of negative 4 easily, because the square root of 4 is a perfect square. Now, we know for certain I is going to come out. Since we have the negative inside the radical, that negative comes out as I, and the square root of 4 is 2. Then we'd have to solve for x. But is x by itself? So it tells us x is equal to plus or minus 2y. And that's it. So yes, there are no real solutions because our solutions for this are positive 2i and negative 2i. Those aren't real numbers. So we don't have real solutions. We have complex solutions of 2i and negative 2i. Now we could check it. We can grab the graphing calculator, save and quit, and say parentheses 2i squared plus 4. Because all I've done is what? Replaced x with, when our solution's 2i, yes? And what should this equal? Well, 0. That's what the equation equaled, yes? And this tells us that it is indeed 0. I can do the same thing with negative 2i squared plus 4. And this should also equal 0. It checks. It says that these here, positive 2i and negative 2i, do indeed make the equation x squared plus 4b 0. Questions on this here? We ready for the next one? 2x squared minus 11 equals negative 47. Again, most likely, especially since we're covering it right now, graphing's not probably going to work because it's probably going to give us an equation with complex solutions. But the nice thing is that the only variable we have in this equation is x squared, which means we can use the square root method. So what's the first thing we can do in getting the squared term by itself? Add 11 to both sides. Negative 11 plus 11 is 0, telling us 2x squared is equal to almost negative 36, because negative 47 plus 11 will give us negative 36. Now, negative 47 minus 11 would indeed give us negative 58. Now, is the squared term by itself? No, so we would need to what? Divide both sides by 2. Two x squared divided by 2 is just going to be x squared. Now, negative 36 divided by 2 is negative 18. Is the squared term by itself? Or yes, we just have x squared, so it is by itself. There's nothing being multiplied anymore, nothing being added or subtracted from it. So what can we do? We can square root both sides. Now the square root and square will cancel, giving us x is equal to plus or minus. Yes. Now square root of negative 18. The graphing calculator will tell us that it is 4.242640687i. Yes. So it says that the square root of 18 does not reduce nicely. Now the 30xs, as we can see here, can take the square root of 18. It just cannot take the square root of negative 18. But we know that the negative inside this radical is going to come out as what? I, yes? Which means now we're really just looking at what the square root of 18, we're just trying to find it. And I'm just writing this over here so we can kind of mentally see what do we have left to simplify. And the square root of 18 simplifies to 3 square roots of 2. Meaning that the square root of negative 18 should simplify to 3i square roots of 2. So the 30xs is very nice in simplifying these radicals. But we do kind of have to do this in-between step of removing the negative as I and then letting it do the rest of the simplifying for us. Questions on this here? And the reason this works so nicely is because, again, we can use the square root method. We can get the variable being squared by itself, square root both sides, and then we're done. Yes? Even 4x squared plus 20. If we're trying to find zeros, we're trying to find out what value of x will make this equation be 0. There is no middle term. There's no x to the first power. So the first thing we can do is get the square term by itself. So we would subtract 20 from both sides. Those cancel, telling us 4x squared is equal to negative 20. What can we do next? By? We divide both sides by 4. 4x squared divided by 4 is going to be x squared. Negative 20 divided by 4 is negative 5. Is the x squared term by itself? Yes, so that means we can square root both sides. And the x squared and the square root will cancel, telling us x is equal to plus or minus. Now the square root of negative 5. Well, the negative is going to come out as I. And what that leaves us with is the square root of 5, yes? And what is the square root of 5? Square root of 5. Personally, I always put the I in front of the radical if we still have a radical left. There is a lot of places that will put it after, but I've seen too many times that that I will want to move inside the radical just as we're writing it or as we're continuing solving. It tries to creep inside or scoot inside the radical, but that I got pulled out. We pulled it out the negative one as I. We're not putting it back in. So I put it in front just to verify that it is outside the radical. Now, when we start having some of our answers like we did before, the square root of 26 over 2, then we can put it, we'll sometimes put it after that, like we did on 2.42, because that fraction really prevents it just from scooting back inside. Questions on this here? So solve x squared minus 16x plus 64. Now, can we just use the square root method on this here? Well, not necessarily, because, well, square root method only works if what? The only variable we have is either what? X squared, or the variable is inside a set of parentheses being squared. We cannot have a middle term. We cannot have x to the first power. So here, having the x to the first power really prevents us from using the square root method. But we're going to do something a little weird, or at least it's going to seem weird. We're going to factor x squared minus 16x plus 64. We're going to factor it first. We're going to leave the 100 on the other side. So when we factor x squared minus 16x plus 64, first thing we would look for is the greatest common factor between these three terms. Well, there's not one. Now we're going to find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is positive, so the signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Now we need to find the factors of the first and third term. Well, factors of x squared are x and x. And realistically, that's the only factors of x squared. Now our factors of 64. We have 1 and 64, 2 and 32, 4 and 16, and 8 and 8. And the first set of factors that we're going to try is going to be 8 and 8. Now we can check this here. X times negative 8 would be negative 8x. And negative 8 times x is going to be negative 8x. And negative 8x minus 8x is negative 16x. Is that the middle term we wanted? Yeah, okay. Now what's interesting about this here, if we look at the left-hand side, what do we have as our factors? X minus 8 and x minus 8, yes? The two factors that we have are the same. They are the exact same, yes? Is there a way that I could rewrite x minus 8 times x minus 8 a little bit simpler? Because we could rewrite it as x minus 8 what? Squared, yes? Because all a square says is that it's being multiplied by itself, yes? Well, wait a minute. Now can we do the square root method with this? Well, yes. Now the whole reason we could rewrite x squared minus 16x plus 64 as x minus 8 squared is because this here is what we call a perfect square trinomial. Perfect square trinomials can be rewritten as a single set of parentheses squared. And since we have that, I can take this and square root both sides, because the left-hand side, the square root and square would cancel, telling me that x minus 8 is equal to plus or minus 10, because the square root of 100 is 10. Since we're able to rewrite x squared minus 16x plus 64 as x minus 8 squared, we are now able to use the square root method to solve this here. Questions on this so far? Is x by itself? No, so what do we need to do? Add 8 to both sides. Negative 8 plus 8 is 0, leaving us with x by itself. Since we added 8 to positive negative 10 plus or minus 10, we need to put that positive 8 in front of the 10, telling us that x is equal to 8 plus or minus 10. Yes? Now at this point here, we could say we're done as long as 8 and 10 are not like terms. 8 and 10 are like terms, yes? Because is it possible for me to calculate 8 plus 10 without turning it into a decimal or having to approximate one value? Well, yes, because 8 plus 10 is what? 18. That means we can also do 8 minus 10, which is negative 2. So 18 and negative 2 are the values of x that will make this function be true. They are our solutions. Now this also means that we could have graphed this and factored it because we got integer answers. But the interesting thing is that if we have this perfect square trinomial, we're able to write the x squared minus 16x plus 64, this ax squared plus bx plus c, as a single set of parentheses squared. We can actually do the square root method. Doesn't matter what's on the other side, it will work. Questions on this here? So if we look at this next one here, x squared plus 4x plus 4, this here is a perfect square trinomial. Since the third term is positive, our signs are the same and match the sign of the middle term, so we'd have x and x, or plus and plus. Factors of x squared, there's our x and x. And our factors of 4 are 1 and 4 or 2 and 2. Pause for a minute there, but part of the reason we want 2 and 2 is, again, we want to be able to rewrite this as a single set of parentheses being square. And the only way we can do that is if these two sets of parentheses, these two parentheses are the exact same. And since they are the exact same, we can condense it down to x plus 2 squared. Questions on this here? Now at this point here, we can do what? Square root both sides. And the square root and square on the left-hand side will cancel, telling me x plus 2 is equal to plus or minus 6. Next thing we can do is subtract 2 from both sides, telling us that x is equal to negative 2 plus or minus 6. Negative 2 and 6 are like terms, because if it had been, say, negative 2 plus or minus the square root of 6, we're done, because square root of 6 and negative 2 aren't like terms. We can't add, we can't subtract. But with negative 2 plus 6, we can simplify that. Negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. Questions on any of this here? Questions on anything we've done so far? So looking back at this one here and the one we did before, what is the big thing that really made this work? is what? Let's get a highlighter. That's got a highlighter. There's a highlighter. Is that this side here, the x squared x and our constant term were a perfect square trinomial that we could rewrite it as a single set of parentheses being squared. Because if it wasn't, that means I couldn't rewrite it as a single set of parentheses squared. I couldn't just take the square root of both sides and solve. The real key to this is that the x squared plus 4x plus 4, this was a perfect square trinomial. Yes? And that's what the next method we're going to learn about solving, completing the square. That's what the key to it is making it into a perfect square trinomial. Is given the equation, we want to set up one side to be a perfect square trinomial so that we can take the square to both sides and solve. Now to do that, so we're looking at the x squared plus 14x plus c. So 14x squared plus 14x plus c, we want to make this into a perfect square trinomial. We want to find out what value of x or what value of c will make this into a perfect square trinomial so that we can rewrite it as a single set of parentheses being squared. Now to be able to do this, we need one piece of information. The fact that the value of c is equal to b over 2 squared will give us, this equation will give us the value of c we need to have this perfect square trinomial. Now the general equation for a quadratic is ax squared plus bx plus c. And when we're doing this here, this completing the square, making this perfect square trinomial, the value of a will be 1. The value of a is going to be 1. And if it's not, we're going to make sure it is. Now, when we look at this here, the one real value we need to be able to plug in is b. And what's our value of b for this here? 14. More specifically, it would be positive 14. So the value of c here is going to be positive 14 over 2 squared, our b over 2 squared. So the first thing we want to do is divide by 2. What is positive 14 divided by 2? 7. And 7 squared is 49. So what that's telling us is that our perfect square trinomial, given x squared plus 14x, its value of c that would make it be a perfect square trinomial is 49. So x squared plus 14x plus 49 is a perfect square trinomial. Now we need to factor it. We need to rewrite it as a single set of parentheses squared. And we did this already a few times today. We had our two sets of parentheses. We found the sign. Factors of the first and third term. Worked all the way through this here. There's a little bit easier way to do it, especially once we found the perfect square trinomial using this here. We're going to have x, because we're going to make sure the number for a is always 1, so it's just x. Now the number and sign that go inside the parentheses with this x is the number inside the parentheses before we squared it to find c. And the number inside the parentheses before we squared it to find c was 7. And it was positive 7. So that means it's going to be plus 7. If it had been negative 7 inside the parentheses before we squared it, it would have been x minus 7. So we take the number and sign inside the parentheses before we square it and find our value of c to help us find its factor. So the perfect square trinomial for this here is x squared plus 14x plus 49. The factored form of this is x plus 7 squared. And that's it. Questions on this here?
You just, can't you just find the square root of the second term and then look at your second sign again.
So the square root of 14 would be 2 square roots of 7. Yeah, it wouldn't work out as nicely. It seems like it should. But yeah, no, we just take that number, divide by 2, and square it to get there. But yeah, it's kind of what you're getting at is the same thing. But it's more you're square rooting it to square it. It's kind of undoing itself. But I get where you're coming at. Yes. We ready for number 4? Yes. So x squared plus 8x plus c. Well, to find this value of c is equal to b over 2 squared. And for us here, the value of b is 8, and it would be positive 8, yes? Questions on how we got this set up so far? Now, 8 divided by 2 is 4. And 4 squared is 16. So we can replace c with that value, telling us that our perfect squared trinomial is x squared plus 8x plus 16. Questions on how we found c? Now our perfect squared trinomial would be x plus the number in plus or minus, depending on the sign, the number inside our set of parentheses squared before we, or number inside the parentheses before we squared it to find c. And that number in this case is positive 4. So our factored form of this would be x plus 4 squared. And that would be our answer. Especially on the homework for these here. It'd be x squared plus 8x plus 16. And then the factored form would be x plus 4 squared. All right, let's look at the next one. X squared minus 2x plus c. What is the value of b? Negative 2, because we need to take the number and the sign. Now, it is very tempting because we could put parentheses negative 2 over 2, close parentheses, squared, hit enter, and let it do it for us. But it is nice having that number so that when we factor, we see what it is. Because negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Telling us that the perfect squared trinomial for this here is x squared minus 2x plus 1, yes? Factored form. So we still have x. Now the number that's going to go in there with x is the number in sign of the number before we squared it to find c. In this case it is negative 1, so we will have x minus 1 squared. That's the nice part of actually doing the division of 2 first before we just square it. We just plug it all in and square it, because it tells us that that number that's going to go inside the parentheses with x is negative 1, telling us that we have x minus 1. Does that make sense? We ready to look at the last one? C is still equal to b over 2 squared. What's our value of b in this case? Negative 9. So we have negative 9 over 2 squared. Negative 9 divided by 2. Does negative 9 divide by 2 nicely? It divides into a decimal. And for most things, in a lot of places in math, having it as a decimal works a little bit nicer than fractions. In most. Here, it's going to be better to leave it as a fraction. And since we can't simplify it, we can't reduce it, this is as simplified as it gets, we're just going to go on and square it. Negative 9/2 squared is 81/4. telling us that the perfect square trinomial is going to be x squared minus 9x plus 81/4. And if you're wondering, yes, the value of c is always going to be positive because we're squaring b over 2 squared. Because that number being squared, even if what's inside is negative, it's going to come out as positive. Now we're having to factor for this here. But what's the number inside the parentheses before we squared it? Negative 9 over 2, which tells us that our factor form is going to be x minus 9/2 squared. 9/2 squared, yep. And that's it. Questions on this here? I'm going to borrow this for a second. So, homework. 3, 5, 11 through 18. I'm going to be nice on 3 and 5. I'm not solving it for you, but I am giving it to you in factored form. So I'm really doing the first main step to factor it for you. You just have to solve it from there. 11 through 18, you're finding the value of c. Make sure to write the perfect square trinomial just like we did, and then find its factored form. And that's it.